Okay, so hello everyone, and thanks for joining us today. My name is Andres Velez, and I'm the product manager for AutoTURN. Today we're going to go over three key aspects of AutoTURN that might help you perform different types of analysis for your roadway infrastructure. And before we start, just as a reminder, this session is going to be recorded, and you will receive a copy with the corresponding link to watch the session on your email. So with that said, let's begin with our presentation. So here's our agenda for today. As usual, we'll start with a quick introduction about AutoTURN and some key elements that have made the software the de facto standard when it comes to vehicle simulation and swept path analysis. Then we'll have a look at the research and development of AutoTURN, which will help me to introduce the improvements we have done for special transport vehicles. And those improvements were recently added into AutoTURN in version 9. And right after that, we'll proceed with our technical demonstration, given that you have all the background about the field test, the results, and how things work. So we'll put some of these elements in practice. And then the last 15 minutes of today's session will be dedicated to Q&A. However, if you have any questions during the presentation, feel free to enter them at the QA section of your GoToMeeting interface or through the chat, and I'll be happy to address them at the end. If due to time reasons I can't address the questions during the session, I'll be contacting you via email and with an answer for sure. So let's go ahead and start with our introduction. As you might be aware, AutoTURN has been the most widely used swept path tool for 25 years, and this is demonstrated by its adoption. Over 85% of DOTs in North America and more so over 120 countries use AutoTURN for their vehicle simulation and swept path analysis. This is also demonstrated by our involvement in the development of the turning templates in the AASHTO 2011 design guideline. Also demonstrated by our collaboration with DOTs like WSDOT and Caltrans in the development of regional libraries and vehicles with specific turning characteristics. This is also demonstrated by the adoption of AutoTURN Pro by other DOTs like PennDOT and WSDOT for the evaluation of designs such as rail crossing, clearances to structures and surfaces, and to verify vehicle access for emergency vehicles in 2D and 3D. And last but not least, we have been playing a more active role in terms of research. We have submitted and presented white papers in different design conferences, such as the International Highway Design Symposium, also at the annual conference from the Transport Association of Canada. And we recently submitted a paper, and we're expecting to be presenting next year at the TRB conference, which is a major step for us. And being used in over 120 countries, and since our intention is to provide the best possible customer support, we have offices in different parts of the world to ensure that our support times have the minimum turnaround. Our headquarters, as you might be aware, are located here in Richmond, British Columbia, Canada. But some of our offices are located in the Netherlands, Sweden, India, and Australia as well. Another key aspect of our development is are the vehicle libraries. And this is something that is also key for our customers. And we want to make sure that you have the latest and more relevant vehicles according with the most recent design guidelines. So in every development cycle of AutoTURN, we spent a lot of time making sure vehicle libraries are kept up to date. Then we have the more recent and more relevant libraries included in the software. Just to give you some examples, recent versions of the program incorporate the following libraries, or the libraries you can see on the screen in the case of North America, and those include, of course, ASHTO, TAC, NACTO, NCHRP 659. We'll be using some of these vehicles today, low clearance vehicles. ILDOT, INDOT, WISDOT, oversized, overweight vehicles, also vehicle libraries for Caltrans, VCMOT and VCMOT over length in the case of Canada, most particular British Columbia. And just to give you an idea, worldwide, AutoTURN includes libraries for 35 different countries around the world. So if you, for whatever reason, are looking into other design guidelines, or you're interested in checking other vehicles that are documented by other guidelines, you can definitely use AutoTURN and have those vehicles there as a reference or to perform the analysis. Now let's start with research and development. So when it comes to the development and the improvement of the tools within the software, we typically do our homework and involve a lot of research from our engineering team. This timeline illustrates some of the most important field tests Transoft have conducted in the past, not only to verify the accuracy of the software, but also to improve existing functionalities and develop new ones. Our latest field test, in collaboration with Vestas, helped us to verify the results of the software when it comes to modeling special transport vehicles. And this study also allows us to incorporate the ability to specify steering linkages for special transport vehicles. And this will help them to, or now we're leaning towards special transport, and this is our first subject for technical demonstration. But just to give you a little bit more background on it, as I mentioned, our primary purpose was to verify the accuracy of AutoTURN when it comes to the modeling of these vehicles. This field test took place in Oregon, United States back in 2013, and it was done by Transoft Solutions in collaboration with Vestas Wind Systems. We used some of their trailers and equipment, and we essentially what we did as part of the methodology was to locate GPS at specific points of the load, the trailer, and then we recorded the trajectories of each of these components. This data was then transferred or converted to AutoCAD, and the last thing we did was to reproduce the vehicle, same characteristics, turning information into AutoTURN, and compare the envelopes for the cab, the blade, and the trailer. I'm sorry, and also the tail of the wind blade that you can see on the screen. And we compared those. So as you can see from this summary of the results, AutoTURN simulations can reasonably simulate the actual vehicle path. The higher discrepancies that were observed for the tail, we noticed it could be due or can be the result of the vehicle scrubbing the gravel surface. So differences in friction values, and you know you can control those values in AutoTURN, might have affected this. But overall, when you see the overall vehicle length and the swept path width, our distances are in a very accurate position or results. Now, as I mentioned before, this field test also allowed us to introduce the steering linkages now that we acquire a better understanding of the vehicle behavior, and also after taking a good look of how is an industry standard to present this turning information of the vehicles in a particular way. So we developed this functionality based on the result. And this allows you to specify the linkage between the rear steer axles and the articulating angle of the vehicle in kind of a format that it's provided by the vehicle manufacturers and follows the industry standard for this. Now, well, so now that you have some background information about these capabilities that were added to the software, we might as well take a look at the vehicle and vehicle configurations that are or that can be supported or configured in AutoTURN. Of course, the first and simpler type corresponds to just a front steer lowboy or flatbed trailer. And these vehicles can easily be modeled in 2D and 3D in AutoTURN. You can see the small icon on the right-hand side of the first vehicle indicates that the vehicle is 3D capable. Our next type of vehicle corresponds to an independent rear steer vehicle, such as the wind blade that we just saw in the pictures and on the field test. For these vehicles, you can configure steering linkages for the rear steer axles. And for low speed maneuvers, oh, hold on, we have, let me see if everything's going okay. I just have my interface blinking. So I just want to make sure that, yeah, apparently we're good in terms of audio. I was afraid we lose it. It's okay. Okay, so coming back to our presentation, this wind blade trailer has rear steer, or the ability to specify independent rear steering and specify the steering linkages. But also, as I was saying, for low speed maneuvers, the steering of the rear steer axles can also be controlled manually. I'll show you how to do that during our technical demonstration, but essentially you can manually change the steering, and as the second driver of these vehicles will do in real life, and you'll be able to control that and go around obstacles. And the third type of vehicles that we have corresponds to vehicles where the cargo length determines or influences the length of the trailer. And a good example of these vehicles is the wind tower transporter, which you can see here, small example. So in this case, it's really the cargo what's going to influence not only the length, but also the off-tracking and the swept path of the vehicle. And vehicles using these cargoes can be defined in AutoTURN, and the cargo length can be specified in a specific section for the cargo details. And that's how you can control the length. And then these vehicles will also have the ability to specify independent rear steering, and also to control the steering manually if they have been defined in that way. So at this point, and after giving you an overview and a little bit of background of special transport vehicles and which types are supported right now by the software, we can switch to our technical demonstration. So I'm going to ask you to bear with me for a second while I switch to AutoCAD for a moment. So, okay, we have our scenario here. Oh, hold on. Just do it this way. Okay. And this is our first scenario. It's a roundabout that contains terrain information. Just to make sure that you guys can see my screen, would you be able to please confirm in either the chat or the Q&A session that you're able of seeing my screen right now with the AutoCAD drawing? Hold on. Okay. Yeah, let me see. Okay, good. So we're good to go. So for our first scenario, we have runabout, and since we were talking about special transfer vehicles, Let me show you where all these parameters are defined. So in recent versions of the software, most particularly in version 9, and after the field test, we incorporated a quite comprehensive vehicle library of special transport vehicles. And the idea was to give our users a starting point when modeling these vehicles. So you'll find all sorts of vehicle configurations for different purposes. So we have booster trailers, we have wind blade trailers as well, wind tower trailers, and you can see depending on what the vehicle does, you will get a different configuration. In the case of the wind tower trailer that we were looking at the end of the slides, we can see here now that we have the vehicle configuration, and then we have the option to control the cargo length and also to control the steering linkages. All these vehicles by default, the ones shipped with software, use a one-to-one relationship for the articulating angle and the steering of the front and the steering of the rear axle group. And the same thing happens with the length. However, if you have manufacturer specifications, you can always copy the vehicle and then change its characteristics. So here, if we go to the cargo, we can control the length right now. Let me just switch back to feet. And we can control and make it shorter, in which case you can see how it shrinks and you get instant feedback of what's happening with the vehicle. Something similar happens for the steering linkages. So at this point we can add and specify different values for the articulating angle. Just delete one row here. So we can specify, okay, when the articulating angle is at 20 degrees, the front steering angle or the axle, the front rear axle steering is going to be at 60 degrees, and that will make the turning quite dramatic. And I'll show you an example of this in a minute. So this for the wind tower trailer, and you can see how you can control the length of each component. I'm going to cancel here, and then for this first example, we would like to use a vehicle with a similar configuration to this wind blade trailer that we have here. And I'm going to show you two things about this. One, how can we use the load shape capabilities to model this, this wind blade. And as you can see, the vehicle here only shows what the vehicle body is. So we're missing kind of like the cargo, which is far longer or a bit longer than the actual vehicle length. So we can expect to have an envelope or a different envelope produced by this wind blade. So the way to do that is, again, we can select this vehicle and copy it, and you're going to get a message right away saying, okay, this vehicle was used or was created originally using the effective wheelbase method, but you can, if you click yes, or you can switch and use the steering linkage method, or you can keep it as the effective wheelbase one. So just by saying yes, you'll get the vehicle creation interface, which is also new for AutoTURN 10. And here you can control the steering linkages for this part. Before doing this presentation, just to save a little bit of time, I created that vehicle in advance. So since I made a copy, I can go to my custom vehicle library over here. And I had a wind blade trailer example. So this vehicle has similar length and characteristics as the one you're seeing on the screen, on the left-hand side of the screen. So we're going to use this wind blade to go over our example. So we can select the vehicle right away, and let's go over our roundabout. So for this vehicle, if we go back to the default, you can see I have already changed the relationship between the articulating angle and the rear steer angle. So if we keep that, we delete that. So this is how the vehicle will behave by default. If we say okay to this, we can at this point add our load. So let's do that before we actually go and simulate the vehicle. Let me just say okay to that for a moment. Go over here. And now the first thing we would like to do is to add this wind blade to our vehicle. So again, we go to our vehicle interface, and I'm going to do this fairly quickly. We go to our vehicle details, and here the interface allows us to define 2D loads. In this case, let me just move my interface over here. So in this case, I have modeled this this wind blade as a closed polyline, but it can be a complex chain or even just lines and arcs, as long as they're closed. Then we can go to our second part and add a load to this part. We can do that by importing the load. The first click is to select the object, and the second click will give us a reference point in regards to the vehicle part. So we know it's going to be around here. And now our part has been added to the vehicle. We can change the name of the load to wind blade. And then in here we can also control, if we pick the wrong point, we can still control the front distance. So right now it's correct, but just to show you an example, I'm going to type some values so it's just 1 foot forward. But we can make this a little bit more dramatic so that you can see the effect. So I just move or shift the load 10 feet towards the front of the vehicle. So now it's actually hitting the cab. So we can put it back to where it was. We can also control the side distance if we would like to, indicate which side, and then we can also have the cargo angle. For now, let's keep it as is, and let's say okay to this. We can say okay to this as well, and okay to our vehicle interface. And now we can go back to our roundabout over here. And let's say we want to check this movement going from the west and entering from the west and then exiting towards the north of this roundabout. One thing I would like to do first is check my properties. I'm gonna just remove this for a second so that we can see the envelopes better. And now for 2D, we want to show our loads in blue. We can set up clears for this load if we want to. And then just to make sure that now we're sure that the envelopes will be produced, and now yeah, we have the loads checked. So we can start driving our vehicle using Allopath. You can see now the load is attached to the vehicle. We can, let's say, place it somewhere over here. And then we can start moving the vehicle. So you can see on a 1-to-1 relationship, the rear axles are going to steer 1 degree for every degree of the articulating angle for the vehicle. And you can see how the AutoSteer works. However, if we were to drive the rear steering as independent, we can check the manual steer option. And now we have control of the steering of the rear axles of the trailer. So by pressing the control key on your keyboard and using the scroll wheel, you can see how as I scroll down, I'm controlling the angle for this vehicle. And I can say go over here, and now it's too tight, so I can undo that section and try to go wider so we can accomplish the turn, and we can keep scrolling until we kind of see that our wheels are gonna go away from the center of the runabout. We can zoom out a little bit, that will make our life easier, and we can try to move to the next section. You can keep changing the steering of the rear axles and keep going. And they will keep that, that angle until we either scroll back to the default position, or at this point we might be able to switch the manual steering because we know we have overcome the center of this runabout, and just keep going. So that's the example. You can see the envelope produced by the load and also the envelopes produced by the rear tires of the vehicle. We can animate this and see the behavior. So from that point we started controlling the steering. You can see now the vehicle turns, and we can avoid that. The wind blade will penetrate or penetrates the center of the runabout, but these vehicles can control suspension. They can actually lift the load, so we would say there's probably not an issue there. Now, to show you the effect of the steering linkages, let me just give you a quick reminder of how the vehicle it's working over here with a one-to-one relationship. Now, let me just delete the simulation first. And now if we go back to our vehicle interface, we select our vehicle again, and let's say we want to change the way the articulating this linkage works. So we can define, like, for a 35, let's make it 20 degrees of articulating angle. We're going to have our rear wheels steer at, well, 35 degrees will probably do it, but what I'm going to do is make this a little bit more dramatic. So for a 15 degrees articulating angle, or rear steer wheels are going to be steered at 35 degrees. So that makes the turning a lot more dramatic. If we say OK to that, we say OK to the vehicle. Now I'm going to place it roughly at the same position. And you can see now when I start turning, the vehicle actually goes a lot wider. And we're doing very low speed simulations. So again, for a vehicle defined or using this steering linkages, we may want to control the steering of the rear with the manual steering option, and then press the control key. And you can see it's it went back to something that's more manageable for this runabout. We can keep going, and we can keep trying to avoid the obstacle. And again, you can see over here how the steering of the rear, oh, sorry about that. Let me just press control again and keep varying the manual steering angle. So we can go over there and then keep driving. Maybe we can start strengthening the vehicle a little bit. Now we have passed the obstacle, and then if from this point the vehicle is ready to keep going, we can switch back again to AutoSteer, and then the wheels will follow the trailer with the proportion indicated on the steering linkages. One final note here, let me just place that to show you. The manual steering, of course, is only available for low speed simulations. So if we go over 10 miles per hour, you won't have that option available for the independent rear steer vehicles. So you have seen now how the linkages behave in AutoTURN, how can they be specified in the software, and also how you can control manual steering. In addition to that, you have now learned how to use the load shapes, either to mold these vehicles or in general any cargo or element that protrudes the vehicle body. For our next example, now going towards ground clearance analysis and verification of vehicles in 3D. We're going to keep using the same example. So you can see for this runabout, we have defined our surfaces, we have our gradings here, and our slopes, I'm sorry. So for that, I would like to use one of the low clearance vehicles that were incorporated recently in the software. And the NCHRP report library contains a lot of low ground clearance vehicles. In AutoTURN, you can specify different ground clearances per vehicle part. So if we take this Lowboy as an example, if we go to the roofline view data, you can define the ground clearance for the front and the wheelbase, and for the second part, again, for the wheelbase and the rear. So this will allow you to realistically model the underside of the vehicle and get the right or perform ground clearance analysis in a more accurate way than just assuming one single value that might cause some false positive when performing the analysis. So for this vehicle, we have those ground clearances defined. We can go back over here and say okay to this. And then what we're going to do is just first produce the simulation in 2D. So we can say this guy is going to go over here. And then just a small reminder of what AutoTURN does. We can control the speed, although I think this runabout is quite big. So I'm pretty sure this vehicle will be able to go around without any major issues. And then we can perform the same maneuver. Going over here. And now that we have checked this vehicle in 2D, we can start using the terrain information that's on this model. So we can select the terrain first by picking this triangulated surface, and then we can convert our vehicle from 2D to 3D. So when you go to AutoTURN Pro, previously created simulations using previous versions of the software can be converted in 3D. You don't need to redo your work. And just by selecting the terrain and picking your simulation, you can fairly quickly convert it. Let's say for this example, I want to keep the 2D simulation in the background. So I'm going to say OK. And you can see now we have some conflicts indicated between this low ground clearance vehicle and the surface of this runabout. So we have an issue over here. We have also like a larger conflict over here on this area, and AutoTURN is highlighting this conflicts with the vehicle. There's another thing that AutoTURN will account for, and these are the vehicle limits in 3D. So when you customize vehicles, you might get specifications for the pitch and roll angle limits at the articulating point of the vehicle. So having those limits, AutoTURN will account for this, and it'll stop the vehicle whenever your terrain is causing those vehicles to be violated. For now, let's leave it the way it is. You can say OK to this, and we have our conflict here. So if we orbit this a little bit, let me just do it fairly slow. So you guys can see we have our vehicle somewhere over here scraping the surface. Let me just change to a realistic mode so we can see it a little bit better. And you can see how yeah, this vehicle is having some conflicts here and there. We can animate this. And okay, we have our interface there. So a couple of things that I would like to show you here before we actually work a little bit more on the analysis. In the case of the run animation, we incorporated the ability to preset, or we have some preset cameras using the driver's eye location, for example, or well, you can use the current view, and you can also produce a video. So export this as an AVI file. Just to show you quickly what it does, we can go to the driver's eye, and we can see well, what the driver will be experiencing while driving the vehicle. And we can produce a video of this just by clicking the record button here. You can change to another view, and the whole purpose of this is to make just go back all the way to the beginning, is to make this rendering option a lot more useful and make it more straightforward. So we can close this now and now go back and focus on the analysis. So we can see we have the 3D envelope of AutoTURN has already identified some issues there. So let me just switch back to our 2D view and then go to our top view. Okay, just rotate it this way. So there are tools in AutoTURN that will help you assess how bad the conflict is. So we can use the punch-through report, and now we can generate multiple sections. So if we draw a line over here, for example, say right there in the middle of our conflict, we can use the punch-through report tool, pick our simulation first, and then the section line that we want to use as reference. And that's going to give us this first section over here. And now one thing we can do is to generate multiple cross sections at once. So we can define direction and distance and also the interval. So what this is going to do is over a distance of 12 feet is going to generate sections every 3 feet intervals. We can choose what we would like to see, and then if we, let's say we're okay with this, click OK, it's going to generate all the multiple sections for us. And we have, let me show you first in the drawing. So you can get all these sections lines right away, so you can see where each of these sections kind of belong to. So for the first section, we can tell we already have some issues because distance between the envelope, which is the vehicle 3D envelope, which is indicated in blue, and the terrain, which is indicated in green, it's already 0. But then as we move forward, we can see, okay, now the vehicle envelope is penetrating the surface by 0.4 feet. And if we keep going, we can see how our conflict is actually getting worse for this low clearance vehicle. And then as it starts moving towards the exit of, well, further north in our roundabout, the vehicle and the conflict starts to go or to be less severe. So you can quickly generate multiple sections and better assess where the conflicts are happening. You can, of course, set up transparencies for the envelopes and take a look in 3D to what's going on, what the vehicle is experiencing there. And with that, I'll conclude our first example covering our 3D ground clearance analysis as well as special transport vehicles. And I would like to switch now to our second design scenario. We're going to spend a little bit of time over here. So this is, and now we're going towards circulation analysis and IntelliPath, which is one of the latest tools incorporated in AutoTURN Pro. As you might be aware, excuse me, AutoTURN Pro incorporated this tool in its latest version together with the 3D analysis that you just saw. For special transport vehicles, they're supported in 2D, so that it's a capability that you will find in AutoTURN as well as AutoTURN Pro. But the last two examples or exercises, 3D one and this one, are part of AutoTURN Pro. So IntelliPath, as I was mentioning, was the latest tool we incorporated in the software. It allows you to do multiple tasks It automates the vehicle path. It generates, you can generate multiple simulations for a given route with just 2 clicks. So let me just show you a little bit how it works. When we click IntelliPath, I already have the analysis area and some exclusion zones defined for this drawing. So let me just, we can fairly quickly recreate this. So I'm going to delete the analysis area. You can say okay to that. And we can define that. So for this downtown core, we can specify an analysis area. This is again just a closed polyline, and this will limit how simulations, or the space where simulations are going to take place. We can define also exclusion zones, or areas that are not drivable. And in this case, I have closed polylines, but they can be just closed geometry. So we can start clicking here and select all of our exclusion zones. So we have almost all of them selected. For a second. Okay. So as you can see, this yellow boundary that's around, it's indicating the software that vehicles are not allowed to drive on these areas. If we say okay, we get our boundaries highlighted right away. And the next thing we can do is start defining routes or movements. We define a route just by clicking that plus sign over there and just one click to specify the beginning of the route, and then we can start just moving our mouse around towards the direction we want to go. So essentially what I'm doing right now is defining a route that goes from the northwest corner of my screen, or well, this downtown scenario, all the way to the south, and then it does a right turn over here. And let's make it up to this point. If I click right there, let me just change the color of this route, so we can say this is northwest to south east, for example. And we can change the color to make it more obvious to blue. And now you can see we have defined this route. We can ask IntelliPath to give us other possible solutions for that route in case we're interested in doing our side circulation analysis and just see all different ways vehicle can get from point A at the northwest to point B at the southeast. So if we click on this button and we press the control key, you can see it's already giving us another solution, and that's also indicating me that I forgot to select this boundary. So before we actually do that, let me just add that boundary to our session. In this case, the boundary is comprised of just lines and arcs. So IntelliPath switches to a tracing mode in which we can click and just follow that geometry up to a certain point. I don't need to go all the way and close it. IntelliPath knows it's an obstacle, so it's going to be closed. And that's how we can trace geometry to quickly do this analysis. Going back to our route, we can click again the evaluate alternate routes, and by pressing the control key, IntelliPath will give us all the possible solutions to get from point A to point B. Some of them might not make sense, such as this one, which has a problem at the south part. This one is also using the opposite lane. So we can control this and select which routes we would like to follow. This one, for example, makes sense. So we can click to confirm that we want to use that route, and now we have a second route over here. And let me just change the color again to make it more obvious, although we're not going to be using this one. Actually, let me change it to something that's more. There you go. So we have defined two routes. For the sake of this demonstration, I'm just going to use one, but that's how you can define your side circulation. So we just delete this one and say okay. And now we can start generating movements for this first route. So to do that, we can click here to add a movement. We need to make sure the route is selected first. And we have our Lowboy trailer, which is not very realistic for this scenario. So we can change our vehicle, but we can use vehicles from the same library. So we can use, for example, a fire truck. We can choose the speed, so we can make it 10 miles an hour, for example, although we don't want these vehicles to drive too fast downtown. And we can place a vehicle here. Oh, yeah, okay. Let me just do something first, just to make sure that you guys can see the envelope. So I'm gonna hatch the path of the vehicle. And we can go again to IntelliPath, select our route first, and then add movements. Can go back again and change to our pumper fire truck. Say okay. We can control the speed over here, say 10 miles an hour. And now we can place our vehicle from here. First click position, orientation, and then we can go all the way to the end. And IntelliPath automatically generates the movement. Let's add more movements to this so that you guys can see. Let me just uncheck this, and this is gonna keep the movement. It's just not gonna be displayed for now. We can go back here, and now we can check, let's say, for example, garbage truck. Also for this route, we can make it 10 miles an hour again, maybe go a little bit faster, 15, just to see if you can make it. Once again, we can place our vehicle here, again defining our starting point and orientation, and then let's say we only want to have this vehicle coming all the way to here, so the movement is generated automatically. And let's add another one just for the sake of this demonstration, and let's add a delivery truck now for the NACTO street design guideline. So we can go all the way up here, select our delivery truck. This one we may want to use a higher speed, so let's go 20 kilometers an hour, 20 miles per hour, I'm sorry. Say okay to that, and again we can maybe start a little bit forward over here. Let's have this vehicle to go all the way till the end. So IntelliPath is generating the movement, and now it's saying it cannot make it at 20 miles an hour. It won't be able to achieve this turn. So we can change the speed afterwards, make it 15 maybe. And then the movement works all the way to here. We're still going too fast, so we can lower down a little bit, so we can make it all the way to the end. So we have 3 vehicles and 3 movements already defined for this route. And let's say now we want to see the effects of implementing some traffic calming measures. So one thing that I'll do now is just I'm going to check the route first. And then I'm going to change the obstacle definition or the boundaries, so we can account for this traffic calming measures here. We have some curb expansions over here, and we also have a chicane also based on curb expansions over here. So instead of having to recreate all these movements, we can just go here and change our exclusion areas. So I'm now telling IntelliPath to remove those exclusion zones, and I want to add new ones. So I can click the geometry that includes or curve expansions. If I say okay to that, you can see now IntelliPath is recalculating all the movements for all the vehicles automatically. It's already telling us that we have an issue now with the rear load garbage truck from the NCHRP report. It's going too fast and it cannot make it through the chicane that we have here. Again, we can lower down the speed and make it 10 miles an hour, see if that will work. And in this case, it works, and we can get our vehicle all the way up to here. So with that, this is a quick demonstration of how IntelliPath can help you solve what-if scenarios and check the effects of changing geometry without having to rebuild all your simulations. This is the final part of the technical demonstration. So at this point, I'm going to switch back to our PowerPoint. So bear with me for a second. Okay, and just before we go ahead and start with our Q&A session, I would like to ask you a few questions in regards to our presentations and things that you might like to see in the future. So let me just go through a few questions and then we'll go through our Q&A. Okay, so we have our first question there, straightforward. And I'm going to give you just a couple of seconds to go over this. We're still, and please feel free to type in your questions, and we can kind of start addressing this. We have a question here. It says, based on the wind turbine transporter, is 0.2 to 0.3 meters a good horizontal allowance for templates in general? Driver error is a greater factor. It really depends on the trailer manufacturer as well as your infrastructure. They use different clearance values, but most people try to be conservative because these loads are, well, quite big and quite expensive. So in the end, it's really up to the transportation department to set up those clearances. But you can control and you can set up clearances for the load and the vehicle movement. You can vary those from to up to a meter or 3 feet if you want. AutoTURN will generate the envelope for you. Okay, so let's close our first poll and let's launch the second one. So another question in regards to IntelliPath, and we're only going to have 3 questions. So okay, let's keep going over the questions that we have here. Okay. Yes, as I said at the beginning, this presentation is being recorded and it'll be handed to you through an email, so you'll be able to see it afterwards. There's another question, will this work for aircraft? Do you mean IntelliPath? Because, well, for aircrafts, essentially we have tools in AviPlan that allows you to follow geometry, set up groups, and simulate multiple aircrafts going over preset geometry, which is kind of like the way it works on airports. They follow the center line geometry. You can, of course, vary the cockpit over center to switch to the pilot's perspective and follow geometry with a certain offset of the center line geometry. But essentially, rather than automating the movements, what follow path will allow you to do in AviPlan or AutoTURN is to well, define center line geometry and have multiple aircraft to follow it. Okay, for 3D view, yeah. For 3D view, is rendering done in CAD software? Yes, I didn't do much rendering. I only assigned a few materials to the runabout, and that's about it. The vehicle was using one of the realistic vehicles that we have in the software, so you will get a better well, better presentations and better models to present this to our stakeholders. Okay, I can see you guys finished the second poll, and let me just launch the third one, and I'll keep going through all the other questions. Okay, so keep going. Please confirm that IntelliPath is only version 10. Yes, IntelliPath is only version 10. All the other tools were from recent versions of the software as well. So from version 9, we incorporated the special transport string linkages behavior, and then the load shape was added in version 9.1, and we're now in version 10. As I said during my presentation, special transport capabilities are present in both AutoTURN and AutoTURN Pro. However, the 3D part and the IntelliPath part are only in AutoTURN Pro. Is it possible to get a copy of the presentation? You will get the recording. Generally speaking, we kind of keep our slides for us, but yeah, we can discuss via email. I'll be contacting you. Are there videos of IntelliPath on the website? Yes, I believe on the last EDM that we sent you, there was a link for a landing page. You'll find videos of IntelliPath there, just explaining a little bit more how it works and how you can get around with the tool. Does IntelliPath account for Oversteer? Yes, it's only in a different way than AutoTURN. In AutoTURN, you control where the oversteer is triggered. In IntelliPath, what it'll do is IntelliPath uses the steering rate of the vehicle. So if it needs to oversteer to generate the movement, it'll oversteer. Hold on, let's see. Okay. What characteristics determine the different radii abilities at different speeds? Well, the turning characteristics of the vehicles are given by the steering angle and the wheelbase in most of the cases. In the case of special transport, well, you have rear steering axles, so the effective wheelbase changes as well. And the way it works is AutoTURN will check vehicle turning characteristics up to a certain speed, and from there we'll use the actual equation to simulate the movement. So if you're talking about speeds over 30 miles per hour, it is likely that the actual equation or the physics will actually rule the vehicle behavior rather than the turning characteristics. So it's tied to the speed. Does this work on Bentley MicroStation platform? Yes, it does. Okay, let me just, we're running out of time and we got a lot of questions. What kind of turns is it calculating for the IntelliPath compared with placing the vehicle and simulating the turning path myself? Well, the turns that IntelliPath or the movements that IntelliPath calculates are based on the steering of the vehicle. So the vehicle will try to steer and will be constantly adjusting the steering so that it can accomplish the maneuver. So yeah, that's the difference. It works more like autonomous vehicles, where they are kind of scanning boundaries and trying to keep the vehicle center or within a certain parameters. We have a comment here from Vestas, thanks a lot, and they suggest a 1 meter wide buffer for their inside and outside swap path of their vehicles. So thanks a lot for that one. Can you use exclusion zones for double yellow stop bars, etc., without drawing an enclosed shape? Right now, you need to use an enclosed shape. We're doing some improvements in the tool that you will see at the end of this year, in which we're trying to be able to read just open geometry representing lane lines and things like that. We have another one. Okay. Let me just switch back to the PowerPoint. We got a lot of questions, and I'll try to address more at the end. But there's some important information that I would like to give you guys before we go, because we're running out of time. So, in terms of support, we support Bentley, Autodesk, and Brixis. In regards to the PDH, you can or you must register individually. to get your PDH credits. They will be issued electronically through just an automated system, so you don't need to send us an email in regards to your PDH. You can just go to this, or you'll get it through this system. Just make sure that you receive the email from this kind of sender. Now, in regards to one of the questions that I have here from a user using version 9, I won't give you the price. I don't really deal with the pricing part, but there's an end of the year promotion that's available for AutoTURN Pro. So if you want to see details, you can either contact your account manager or go to this link and see what's there for you. And that's the last slide. So I'll go over. Oh, sorry, forgot to close this. So let me just go back to the 2 slides that I think you guys were missing. So in terms of support, we went over this one. In terms of the PDH, you can see now the email address on the screen. So you will get an email with your PDH from this sender. So just make sure you don't have it blocked or on your spam. And the end of year promotion. Now, okay, I'm going to try to go over some of the questions. I think we kind of run out of time already. Yeah, we're 2 minutes behind. So in any case, I'll address those by email, but I can try to respond to them right now. So there's another one. In manual steer mode, is there a way to limit the rate in which the steering is adjusted? Not really. You have to do it. You have to do it manually. You'll be pressing the control key and then scrolling. But that's a function that makes a lot of sense. So we'll definitely consider adding that. Another question: is there a mode for calculating trucks backing up to the truck docks? You can use it. Well, IntelliPath right now doesn't work to produce reverse maneuvers, but there are works around, or it works together with continuous simulation in AutoTURN. So you can let the IntelliPath figure out the forward simulation and then go and click continue simulation and drive the vehicle manually to produce the reverse maneuver. So you can you can save some time by producing the forward simulation using IntelliPath and then switching to arc path or reverse corner path to have the vehicle at the loading dock. We have another question. How easy is to set up the 3 different vehicle movements created with IntelliPath beside each other on a drawing sheet? I think you will have to probably copy movements and drawings one at a time. The other way to do it would be you have full control of which movement is displayed, and as you can see, sometimes the paths or the movements overlap each other. So having one next to the other will be kind of tricky. However, if you want to print them, you can turn on and off and then do different printouts of your drawing. I'd like to see 3-point turn templates. Okay. Yeah, we're kind of working on that. Can the software in Telepath be used to model emergency vehicles such as ambulances, turning path, considering that the movement conflicts will occur at reasonably high speeds? You can set the speed for your vehicles independent of which vehicle you're working with, and IntelliPath will give you an estimation of whether a vehicle can make it or not through. The vehicle, as you saw during the presentation, will stop at the last valid position, and it will give you an indication that it cannot go beyond that point. In terms of the speed, the maximum speed is limited to the maximum speed hard-coded in AutoTURN. So essentially, you'll be able to go up to 45 miles per hour or 75 kilometers an hour, 60 kilometers an hour. I'm sorry. Okay. Okay, I can see. Sorry about there's a comment about the last quick poll. Unfortunately, the way I set it up only allowed for one choice, but I can see there's more interest in the next topic. So yeah, we'll take that comment into account. Thanks so much. Will this program allow you to place parking areas along route for obstacles? You can stop the movement at intermediate points. You can place your movement within the route, but you can stop at intermediate points. So that way you'll be kind of able to account for parking areas. But the thing is, the movement will be generated up to that point and only up to that point. So you will essentially need to define two movements to account for like parking areas or places where the vehicle will stop and then resume the movement. Okay. Um, on the topic, there's 3D analysis of clearance. Yes, we did that part when we produced the multiple cross sections for the 3D analysis. So in this case, we were looking at ground clearance conflicts with the vehicle, with the Lowboy, which is a low clearance vehicle. Ground clearance for the future, we might schedule webinars doing ground clearance, oh, I'm sorry, 3D clearances to structures if you're interested in those. But yeah, generally speaking, 3D analysis or 3D clearance analysis refers to either ground conflicts or conflicts with terrain or conflicts to structures. So if you set up your layers, um, you can account for other elements like road, furniture, or 3D elements within your drawing, not only the surface. There's another question. Can you see longitudinal clearance for ground clearances? Yes, there's an option there which is called clearance report, and that will give you a longitudinal uh, clearance analysis. You can use that, and that's if you do it for the center line, you'll be seeing what the center line of the vehicle will experience. Yes, there are two tools to see cross-section views. One of them is the vertical profile tools. So if you have a vertical profile, you can use the vehicle profile and do a simulation on top of it. If you are interested, I can definitely send you a recording of how the tool works. So that indicates you only have a vertical profile, and yeah, it'll highlight the conflicts. For 3D, you can use that longitudinal clearance analysis as well. Okay, so I'll be sending you those links for sure, so you can see these videos. So that's essentially all I have for today. Thank you so much for joining us. I hope this presentation was of your interest, and hopefully you enjoy it. If you have further questions, feel free to contact us, and I'll be happy to address those. And well, thanks a lot, and see you guys soon.